Okay, so now I'll start. I think this is the recording. Where's my bar? Is it recording or not? Am I missing something? Okay, it's recording. Okay, great. So hello, welcome back, everybody. So it is my great pleasure to introduce Eunice Chan from Western University and Alicia Takaoka from the University of Hawaii at Hilo. They're going to be presenting, of course, they were students last year, and they're presenting an update of their microgrant and project. And the project is called Citation, Contact Tracing, Classification of Retracted COVID-19 Articles. So please, Eunice and Alicia, go ahead.
Great, thank you. Yeah, I'm going to start sharing my screen. We have some updates to our affiliations, which is amazing. I'm currently a lecturer at UC Berkeley, and I teach humans behind the data. And I also recently accepted a postdoc at the Norwegian University of Science and Technology. So I'm Alicia, by the way.
And hi, everyone. I'm Eunice. I also have an update on my affiliation. So I'm currently now an assistant professor at the Chinese University of Hong Kong, Shenzhen in the School of Medicine. So very exciting for the both of us.
Yeah. And today we're going to be talking about citation contact tracing, which is a project we developed, of course, in S4. We're going to go over the background, which is how we began development on this idea, an overview of the proposal points that we hit in the microgrant application, our current research to date, what the next steps are in completing the project, and a timeline for those next steps. So this project built on the work that we did at the Science of Science Summer School. Our group was the COVID-19 citation research retraction team. You'll all get to pick little Slack names and stuff. So that was ours. And at the time, our data set was 46 retracted COVID-19 articles in the areas of medicine and technology, and these were found on PubMed. The data set was used to determine if a bipartite network was present, identify network connectivity among retracted authors, and visually display commonly used keywords, as well as evaluate these papers in which the articles were cited in order to determine if there's a propagation of misinformation. So in 2018, this is one of the big key points. Only one in 2,500 articles, or about 0.04%, were retracted. And then the COVID-19 articles, though, given the short time span, already 134 articles were retracted at the time we did our research. So it was really just a short amount of time. What was that? It was like 7 months. In 7 months already, we were at 0.06% for articles for retraction.
So we have updated the number of retracted articles since then. So we have found 250 retracted COVID-19 articles from 147 unique journals. And this is updated as of July 24th, 2022. So on your right, you can see a graph of the top 20 journals and the number of retracted articles from each journal. And the bars or the columns are colored according to their journal categories. So you can see that most of the journals here are from the life sciences and biomedicine, and the two that are classified as physical sciences are actually multidisciplinary journals. So Scientific Reports and PLOS ONE, they also include life sciences and biomedicine, but since it's multidisciplinary, we decided to choose a different color to highlight those. So generally, the top 20 journals we can see here are basically life science and biomedicine based, which is to be expected due to the nature of COVID-19. Next slide.
So here we have a bee swarm, which shows the retracted articles that we looked at. And this is by when they were published. So we start off in 2020 and we go all the way to 2022, which has already had one retraction. Yay! You'll see that the colors denote the publication type. So some things of note are that we did include preprints, which are the brownish color. And I'm so sorry if anyone is colorblind, if I didn't pick colors that work for you. Please let me know. I'd be happy to change that. You can throw it in the chat or something. And then you'll notice that the green are the most. So by far, the most retracted article, the most retracted publication type were actually articles. And no matter the impact factor, all of these journals where they were published, whether they were self-published or produced by a publisher like Elsevier, they all did undergo a peer review process, which did change in the medical field based on what people determined, like if it was worthy of publication or not. We may touch on that later. And then the bee swarm is also organized by retraction year, which is denoted by size. So these smaller bubbles were retracted in the year 2020, and the larger bubbles, the mid-size bubbles, which are like this size, were 2021, and then the large bubbles are 2022. So we can see that even though that the rate of retraction really is different. Some articles have taken up to 2 years to be retracted, while others took way less time.
So we also divided the retracted articles into journal categories so we can see when they were published. So we have a bar graph showing this. So we can see that since COVID-19 was quite novel back in 2020, we can see that there are more articles there, and due to the process in which many journals decided to expedite their peer review process, we can see an increase or just an overall larger amount in the number of retracted articles that were published in 2020, whereas for each subsequent year, there has been less. So we've also colored it according to journal category. So in life sciences and biomedicine, it had the most with 223 retracted articles. Technology had 10, social sciences had 9, and physical sciences had 8. So just to continue on the theme of the fact that life sciences and biomedicine had the most number of retracted articles for COVID-19. And also we took a look at the length of time from publication to retraction. So we took the number of days it took from when it first appeared online to the day it was retracted. For those in which we couldn't find the retraction date, we just left out. So this is just what we were able to find. And we can see that most of the articles were retracted within 100 days. And surprisingly, there were a few articles that took 2 years to get retracted. So that's an interesting finding as well.
So we submitted a proposal for a mini grant in order to continue this research. One of the reasons is just because we love working together so much. And this project we did feel is important enough to warrant, you know, published research from. And we actually have submitted our proposal to several venues and did get accepted to one, but they wanted us to do a poster instead of a presentation, which was something we weren't comfortable with. So we're pivoting a little bit on that, just spoilers. So in our proposal, we said that we would do 3 different things. So I said that we would classify retracted COVID-19 articles, and this would be based on disciplines. So they're thematic disciplines, like medicine, sociology, and technology. And we would be looking for the strength between their relationships, strong and weak ties, and thematic analysis to cluster articles together. The reason for retraction would also be identified. So yeah. And then the second thing we said we would do is identify the network connectivity of citations. So we would construct a retracted paper network to identify the strong and weak ties among the publications and create a visualization. We would also attempt to identify the propagation of misinformation. So we would construct a citation network to identify retracted node citations and the paths connecting subnetworks. And we will be analyzing primary and secondary citations. And this would be if those citations occurred pre or post retraction.
So let's talk about our methods. So obviously, we need to do a lot of data scraping in order to obtain the retracted COVID-19 articles. So last year, when we were looking at this project, initially, we were only focusing on using PubMed's database. But since PubMed is a database basically for medical articles, we thought that we needed to expand our sources. So therefore, we ended up looking at Retraction Watch to obtain the retracted COVID-19 articles. So what we have here, the 250 retracted articles are up to date as of July 24th. So we actually did an update quite recently. And in order to obtain the metadata, because Retraction Watch basically lists just the article itself, but not the metadata for our analysis, we actually use PubMed's API to scrape all the metadata, especially for the life sciences and biomedical categories. This was particularly useful, especially since the majority of the retracted articles were life sciences and biomedicine. So we were able to obtain all the metadata, mostly for the entire data, like for most of the data set. So for those that we were unable to find, we actually went through it manually, mainly because for keywords especially, which we took a look at, PubMed didn't necessarily have all of the keywords. So we were going through all of the journals and all of the articles manually anyways. So since there were just a few articles, we decided to just quickly go through that by hand. And I also want to acknowledge my volunteer, one of my students, helping me obtain the metadata as well. So lastly, to obtain the journal impact factor and journal category, we use Web of Science. So for the journal category, they actually have a more specific list in terms of the categories. So they break it down into subdisciplines, but because there are just too many subdisciplines, we decided to group it into the 5, which is life sciences and biomedicine, technology, physical sciences, social science, and arts and humanities. So we ended up grouping it into 5 larger, broader categories, but obviously since, for example, life sciences and biomedicine is quite a large field and it can be broken up into subdisciplines. We can also do an analysis on the subdisciplines in the future, but for the amount of time we had and the resources that we had, we decided to just stick with the 5 general broad key categories.
Yeah, and then we also did content and thematic analysis, and Eunice's volunteer generously donated their time as an interrater. We all know that that is kind of underrated, but it's super valued. So for content analysis, I created interrater instructions for how to count keywords by article and identify unique keywords. So it was like a systematic step-by-step. This is what you do, and this is the table you will create. And we use that to calculate percent similarity and determine whether the results are viable. I then calculated interrater reliability, and we applied Web of Science journal categories, and are in the process of finishing identifying sub-themes for the journals themselves. And then for network analysis, we used Network X for the citation networks, and we're using that for the journal networks as well to do the thematic analysis and network analysis for connectivity across disciplines. So stage one, again, what we said we would do is create a discipline network. So that's the journal themes. So, and discipline, right, is sociology, medicine. So, and also those 5 large categories that Eunice talked about and we kept seeing in the earlier graphs. And then we would evaluate strong and weak ties. That is also in progress. And do keyword classification. So interestingly, there were barely no keyword connections across disciplines, which was really strange. I thought there would be a common bank aside from COVID-19. I guess, yes, we will move into that. So for the keyword analysis, the first thing we did was did a count. So based on the 250 articles that we had, what was the number of keywords each article used? And we had a wide range from 114 articles, which includes the preprints, but our preprints did not total 114. There was very few preprints. But they range from 0 keywords used to 11 keywords used. And in there, it definitely seemed like there would be some commonality or connectivity just in keyword usage. But what we found is that there were a total of 696 keywords. The interrater identified 695. Our percent similarities were super high. If you're not familiar with how content analysis works, anything over 80% is considered usable and without further training or retooling. And so anything over 90% is like really amazing. Our percent in identifying keywords, total keywords, was 99.9%. And then the counted keywords, I counted 696 and the interrater counted 694, giving us a percent similarity of 99.7%. And then for unique keywords I identified 446 keywords. The interrater calculated or identified 438 keywords. So this gives us a percent similarity of 98.2%. So that's really amazing. But that number is really high for unique identified keywords. Again, I imagined that we would see more or less unique keywords. Over, what was it, 146 keywords of this 446 were just COVID-19 or variants of COVID-19. So let's talk about these misalignments. So just to give you a composite of our discrepancies, we had a total of 18 misalignments. This is only 2.6% of the entire keyword data set. of those, we had a misalignment of 12 that were identified as COVID-19. Again, that's out of 146. There are 12. There's a discrepancy of 12. So what we did was we changed SARS-CoV-2 and COVID-19 and coronavirus 19 all to align, and just some of those didn't match up. Of the 18%, it is 67%, and then out of the total data set, it is 7.5%. We had duplicates, so only 2, and that's 0.3% of the entire data set. And then we had translation issues. There were 3 translation issues. We're in different countries using different translators, so that definitely accounts for the 3 translator misalignments. 17% of the misalignment subset, but only 0.4 of the total data set, 0.4%. And then just a misaggregation where I didn't, for some reason, catch a SARS-CoV-2. That accounts for 5% of the misalignments and only 0.15% of the total data set.
So now let's move on to stage 2 results, which is the network connectivity analysis. So what we first wanted to look at is whether there is a relationship between journal impact factor, the duration of publication before the retraction, and the number of citations. Because essentially what we're looking at in this case are the primary citations. So what we did was we went through PubMed, because PubMed also has all of the citations, and we scraped all the citations along with their metadata, and we then linked them up together. So in this case, we just did a simple analysis to see whether there is such a relationship between journal impact factor and duration of publication. So generally, you would expect that the duration of publication will have some sort of impact in terms of the number of citations, but we can see that that's not necessarily the case, because the duration of the publication, for example, the one that is closer to the 600 days, didn't receive that many citations compared to the high impact journals. So the 2 big blue dots near the top left, it represents New England Journal of Medicine and The Lancet, and we can see that journal impact factor plays a more vital role in terms of the number of citations compared to duration of publications. Additionally, I wanted to add that the category also affects the number of citations, although you can't see it here. If we had plot instead of the duration of publication on the x-axis, we plotted the journal impact factor instead. You would notice that generally life sciences and biomedical journals or articles receive more citations compared to the rest of the categories, regardless of their journal impact factor. Okay, so in this case, we also then extended to doing a network analysis. So in this network, the nodes are the articles, so we included both the retracted articles and their citations. The edges are the citations. So for example, if article B cited article A, then there would be an edge linking the 2 together. And the colors are by journal categories. And we can see from this clustering that technology papers usually cite similar papers, especially okay, I guess I don't have the annotation tool, that's fine, but you can see that in the middle, there is a clustering of the olive color, which represents the technology, and they all stem from just one paper. Whereas for the rest of the other categories, apart from life sciences and biomedicine, such as social sciences, physical sciences, they usually tend to cite a varied number of journals because usually, let's say life sciences and biomedicine, it spans different fields and they can cite what is according to what is needed. Additionally, as I mentioned earlier, since life sciences and biomedicine is such a big field and it has a lot of different subdisciplines, that makes sense for why social sciences and physical sciences, for instance, would cite different papers among like different disciplines. Whereas for technology, since it is a more smaller field, then we can kind of see why they would cite very similar papers. All right, next slide. And then for stage 3, we did something very similar in terms of what we did for stage 2, but instead of looking at the journal categories, we also looked at whether the citations were published before or after the retraction of the COVID-19 article. So in this case, in this graph that we see in the right, we have the top 15 journals with the most number of citations, and we broke down the coloring by whether the citations were published before or after retraction. So if we were unable to find a retraction date, we colored them in blue, and that is basically stating that the retracted articles, we weren't able to find a retraction date and therefore affected the rest of the citations and how we colored them. But yes, it's surprising that there is a lot of after or post retraction citations, especially for New England Journal of Medicine and the Lancet. And this implies that journals possibly have to do a better job in terms of communicating that journals or articles are retracted and therefore need to. And this alludes to the propagation of misinformation. Next slide, please. So in this case, we also performed another network analysis. So the nodes and the edges are similar or the same as what we saw in stage 2, but now the coloring is different. So we can see from this network graph that it is really dependent on the retracted article to that determines whether the citations were published before or after. So we can see that for the clusterings, when the majority of the citations are published after, typically the whole entire cluster is after. And this is either because the journal in which the retracted article was published did not communicate properly that the journal was or the article, sorry, was retracted, or for any other reason. Whereas there are some better articles in which the majority of the clusters are blue, which represents that they were cited before retraction. So we can see that those particular journals did a better job communicating. So this could possibly be the fact that some journals decide to remove their articles completely so that it is not accessible by people who want to read the article or cite the article, whereas other journals elect to keep the article up. Yeah. So let's also talk about next steps because we want to continue this research. So in this case, we want to also look at the subdiscipline in life sciences and biomedicine for the citation network. So this is from stage 2. So if you recall for stage 2, there were a lot of pink points, and we believe that if we were to look into the subdisciplines for each of the clusters, we could possibly even further dissect each of the themes or categories for these articles. Next, we also want to do a secondary citation network analysis. So this is from stage 3. So in stage 3, we only looked at the primary citation network, but we also want to then see the secondary citation network to see whether the propagation of misinformation, as we like to call it, continues on to the second citation. We also want to do a thematic analysis for the retracted articles on social media. So for now, we were only looking at the citations from journal articles and even preprints, but we also want to see whether this continues on in social media, such as Twitter, and how people share things on social media. Next, we also want to look at retracted article journal network analysis. And lastly, we also want to look at keywords for the top 15 journals by impact factor.
Awesome. And our anticipated timeline for the rest of that is to finish the data analysis by September 2022. As you've heard in our introduction, we have new affiliations, and all of this comes with, new headaches in the transition of getting to the place we're supposed to be. So just we're really looking forward to finishing this up. And then we're going to write up our manuscript of all of these stages 1 through 3 findings. And we've identified 2 journals that we want to submit to. We want to go more to the straight publication route instead of the conference route. And so we've identified 2 journals we want to submit to. And then we, in February 2023 or around there, should start the data collection for the social media piece, which is going to be a second paper. I've been working with an engineer on developing an AI scraper. And so I'm really excited to start testing that out, but I don't anticipate that will happen before next year, even though I would like it to. And so thank you, Daniel and Stephen, for this opportunity, not only to present and share our research, but also for, awarding us funding in the first place and saying that our research is valuable. We will now take any questions from anyone.
Thank you so much, Alicia and Eunice. Very expansive set of research questions and steps. I'm very happy to see it coming through like this. So if there are any questions, please unmute yourself or just ask them directly on the chat.
I have a question. First of all, great presentation. Thank you so much for sharing your great research with us. I wanted to know a bit more about your keyword analysis. If there is any examples of keywords, I don't know if you, how you, probably I missed that part, but how you extracted the keywords. Did you use any computational model, or it was just annotation, or you use the keywords that they're provided by the journals? I would appreciate it if you can provide more info about that.
Yes, so I can talk about the keywords in terms of how we scraped them. So they were from so they are the author keywords essentially. So I know that there are certain articles that provide their own keywords as well, especially like IEEE, they provide their own keywords. And for example, PubMed, they have mesh keywords. So any biomedical sort of journals we look at, or there are provided mesh keywords. Last year, we actually did take a look at the mesh keywords, but we didn't really get anything out of it. And due to our limited resources, because it's essentially me, Alicia, and our part-time volunteer that is scraping all of this data, we didn't have the opportunity yet to look at these other keywords. Alicia, I don't know whether you wanted to expand on the analysis aspect of the keywords.
Yeah, so when Eunice scraped the data, and cleaned it up and shared it with us, I was able to take the keywords, which were all in one column, and then just do a text to column based on a delimited character for the most part. And that's how, and I used conditional formatting to identify the ones with no keywords, and just, copied and then pasted the character instead of the formula. And so that's how we were able to calculate all of the different keywords. So when it went text to column, right, you just have keyword 1, 2, 3, 4, 5, 6, all the way out, and see where it ends. And that's how that went.
Thank you.
So any other questions? So there's a question in the chat. How did you work with mentors? How did you work with mentors, impact the direction and use of tools in your research?
I think that's a really good question. When we didn't really work with the mentors so much in our cohort of science summer school, like we got to meet them and do small groups, and we could ask questions of them, like we could bounce ideas off of them, but we didn't invite them into our Slack or anything. If I'm understanding your question correctly, those are the mentors that you're talking about. And I know that for me, I was more interested in the mentors from a career path trajectory instead of like this sort of research area. If that makes sense. Eunice, do you have anything to add about that?
Yeah, I would say that we also came up with this idea pretty late into the summer school, so it wasn't necessarily in fruition when we had the chance to talk to the mentors. And also with the time differences between you and me and the summer school, this was also a little bit complicated. So a lot of the times when we were talking to the mentors, either it was on a different thought that we had, or if we had already come up with this, it was like little bits and pieces. It's like, what do you think about this? But a lot of what ended up happening in terms of the new progress is from what we had kind of snowballed from the start of the summer school. So we really want to thank Daniel and Stephen yet again to allow us to connect, because we probably wouldn't have crossed paths if we didn't meet through the summer school, especially since we work in very two different fields, and allowed us to kind of work on this project that combined both of our passions in research.
Yeah. And I do want to say though, if you do gravitate toward a mentor based on like whatever they're doing, whether it's their career path, the research they're doing, if you want to work like where they work or something, like don't be afraid to reach out. All the mentors were really open and very approachable, really nice, wanting to work with people. They were very amenable, and like it was, I don't know, meeting them was really cool. Like you get to meet some really cool people. Like we got to meet one of the editors of Nature, and we got to meet someone who was in charge of like a brand new like science policy center, and just the ability to make these connections and like, I don't know, take advantage of that for sure.
Thank you. So any questions? So I have a question. So you probably mentioned this, but the reasons for the retraction, I guess some of the things that, might be influencing the post-retraction stuff, citations, which was very impressive, might be the reason why they're retracted, right? So do you have access to that?
We also did look at reason of retraction, but we weren't able to scrape every everything and organize everything or like clean everything in time to present, but we have a column for reason of retraction, and we do plan on doing something with that in the future.
Yep.
Cool. So any more questions?
Thank you. It's a great presentation. May I ask?
Yeah, please go ahead.
Yeah.
Not a question, but in a study for the social sciences, I found that the articles on COVID in social sciences cited the other articles published after the 2020, for example. I think the numbers are almost 1/3 of the citations references are given in the COVID articles are published after the 2020. I mean, after the pandemic year. So do you have any kind of observation with your data? If I missed, sorry, if you already mentioned in your presentation.
So I wouldn't say that we have concrete evidence just yet, because I think it's still a little too soon, just based off of how long the publication or peer review cycles are for each individual category. So we were actually discussing this the other day regarding how long it takes for someone to go from manuscript to publication. And it actually varies across different fields, because we were reflecting upon our own fields. So my background actually was in mathematics, and then I switched over to medicine. And I already saw a discrepancy between the peer review cycle or timeline. So based on my experience in mathematics, it takes a lot longer to get something published in comparison to medicine. So we can kind of see that COVID kind of exacerbated this effect, because since COVID was so new, a lot of the medical journals wanted to just publish all of the new information as soon as possible. And I think that really shows in terms of what our data provided, especially for the life sciences and biomedicine aspect. Whereas because the peer review process is a lot slower for other disciplines, I think that is where we would see later on possibly what is happening. But I think because of how quickly the turnaround time is for this specific area, life sciences and biomedicine, that is why, well, the majority of the articles, first of all, are life sciences and biomedicine. And second of all, the reason why we're seeing this effect.
Yeah, and we did want to incorporate that timetable into our presentation when so what I was able to find is someone did compile this information, like the duration of time by discipline, but it wasn't updated since the 90s. So that's not super useful. And then the other, so we would have to call different basically like discussion forums, like maybe on ResearchGate, because people have these kinds of conversations all the time, like how long does it take you in your discipline? Again, it would just be anecdotal, though. It's nothing official from the publishers. Does that answer your question?
Yeah. Thank you very much. Actually, yeah. Not a question, but I wonder the other disciplines and other countries in terms of this kind of situation. So thank you very much. Thank you.
Yeah.
Thank you for your question.
Just a quick comment, regarding this question. A lot of journals do publish the receive date, right? So I think that metadata is available. So if you actually wanted to look at individual papers, or you could sample a field and look at the sort of the time from submission to acceptance, which I don't know if that would help with this particular.
Yeah, absolutely. Actually, for another study in economics, I did the exactly what you described. I got the received date from Crossref?
Yeah, I think PubMed has it too.
Yeah,
right?
yeah, they have. So then, but it was in the end of 2012, sorry, 21. So it's kind of very, you know, as Eunice said, it's a very short time after the pandemic started. So, but I am going to look again as you described. Thank you very much.
Yeah, I think using the receive date is a great idea. There's only one thing that I see a little bit of concern with regarding that is because sometimes it takes multiple attempts to get your paper published, and from one rejection to another, authors may not update their papers. So therefore, that could also be an effect as to why there's so many papers that were published after the retraction of the articles, because they just simply did not spend the time to update these papers. So,
Which is, that's an interesting result in itself.
yeah, exactly.
Yeah.
Sorry.
And I was just going to say, one of the papers that we referenced in our proposal actually was mostly retracted citations, but it was because that was what they were talking about. Their entire data, they basically like doxed all of their authors. It had over 100 citations, and it had retracted like in the brackets, and it was because that was their data set. So we didn't actually we referenced it, I think, but we didn't decide to cite anything in it for the reason that, like, having a retracted paper may or may not impact your reputation in your discipline, depending on the reason why it was retracted. And so some of the articles Eunice found, they were like retracted by the author's own desire because they had did an update, or like based on feedback they retracted the preprint and then updated their methods or something. So not all reasons for retraction are nefarious. That's something to point out as well, just that they are retracted.
Yeah, thank you very much. Just it seems that COVID has its own literature, something like that. So yeah, thank you very much.
Okay, so I don't see more questions. So with that, I want to thank the speakers again, Alicia and Eunice. Congratulations on your new position. I don't want to assume a causal effect, but maybe there is attending the summer school, but no, congratulations on moving across continents, both of you.
Thank you very much.
Okay, yep, you're welcome.
Thank
Thank
you.
you, very excited. All right, so I'm going to stop the recording.